Alright, here we go. Just a continuation of the last video on relations. And of course, yes, we're talking about this word functions. And with functions in the last video, relation, remember here was the simple definition of what a relation was. It's a mapping or pairing of any input values with any output values without any restrictions whatsoever. None. A function is a much more specific relation. And here's what I'd recommend running into. There's two definitions, but here's the first one. It's the book definition of what a function is. You need to write it in your graphic organizer. A function is a relation provided there is exactly one output for each input. So it's a specific type of relation. We're not just pairing any old thing. It has to be specifically where one output is going for each input, or is coming from each input. Here's how I like to say it. You're going to see me say this a bunch in class and even throughout these videos. Here's what a function is to me. It's a rule, some type of a rule, mathematical rule, that takes any input value, of which last video we know we called domain, the input value over here, the input value, or the x-coordinate over here, whatever it is, and it pairs it with exactly one output value, what we call the range, or the y-coordinate. So whatever the rule actually is, it takes that thing over there on the left, input, whatever it is, does something to it, that's what the arrows mean, and outputs one particular thing. So you cannot have a situation where an input value is being paired with two things, or three things, or four, which you'll see some examples here very quickly. So jot this down in your notes. I think there's a section there for it. If not, make it. So we have a mapping diagram here, and here's a simple rule. Well, the question, of course, it just pops up, is this a function or is it just a regular relation? Well, if I take a particular rule, we don't necessarily know what the rule is, but we could figure it out. If I'm taking an input of 4 and it's going to output to me a 12, or I input a 2 as an x-coordinate and it's going to output to me a 6, or I take an x value of -1 and outputs a -3, or 0 gives me 0. I don't know if you see the rule or not, but if I had an x value over here, the rule is actually I'm taking 3 times whatever the x value is. That's the actual rule. So my input value of 4, I take 3 times it, get a 12. My input value of 2, I take that times 3, I get a 6. My input value of -1, take that times 3, I get -3. So my rule here is 3 times whatever my input value is. So my domain is anything here that I can put in. My range is what it gives me out, legitimately. Okay? But here's the scoop. As you see, each input value is being paired with exactly one output value. That is absolutely a function. So that is a very, very good function. Yippers, it absolutely is. How about this one? What if I take these input values now and I say the rule looks like this? So 3 is being mapped over here to 9, -1, and also 1 are being mapped to my range value, my y value of a 1, and 2 is being mapped to 4. Now once again, doesn't necessarily matter this, but check this out. These being my x values over here, these being my y values. If I'm looking at the rule, I'm actually taking my input value, my domain numbers, 3, -1, 1, and 2, and I'm actually squaring it. That's the rule. So 3 squared gives me 9, -1 squared gives me 1, 1 squared gives me 1, 2 squared gives me 4. Regardless, though, this, is it a function or is it not? Well, is each input being paired with exactly one output? Yes. This input's only going to 1. This input's only going to 1. Now I know this. Both of these x values are being mapped to the same one, but it doesn't matter. It's okay. That is absolutely a function. Absolutely a function, because each input value is being paired with only one output value. Or the other way around, each output value is coming from only, if you will, one input. You're like, what? Let me give you another example. So this one, absolutely, you betcha, is a function. Check this one out. So here's my arrows. Now, the rule doesn't matter. In fact, I don't know. I just made this one completely up. But let's say 7, my input value is being mapped to 5. -3 is going to -1. And also 3 as an input value is going to 3. And then 1 over here is going to 4. Well, is this, again, a function? The answer is no. It is not a function. Why, Mater? You're crazy. Why? Because each input value, yes, the 7 is being mapped over here to the 5. That's beautiful. But the problem is right here. -3, that input value is being mapped to 2 different output values. It's trying to go 2 different places. Can't do it. That is not a function. It certainly is a relation, no doubt, but it is not a function. Now, you might be sitting there thinking like, what in the world? I'm a little confused. Well, go back and watch it again. Listen to the words that I'm telling you. But here's a simple example. And I'll relate it to you this way in terms of our school. Let's say that you get up in the morning. There's 4 different people. I just make this up. Let's say one is Frank, Sally, Harry, and the guy that's always late, Mark, whatever, it doesn't matter. So let's say that they get up in the morning and they're all coming to the high school. I don't care how this person comes to the high school. Doesn't matter if they come in a bus or she comes and rides a bike, or the little guitar man here walks to school. Of course he would. And the guy that's late gets in a big old race car and gets to school. Doesn't matter. Is this possible? Absolutely possible. Listen, every single day, guys, this is exactly what we all do. We all get up at different places in the town, you know, in different boroughs, wherever we are, but we all come to the same place. It happens every single day. People come from different areas and they go to the same place of work. Wherever you work, people live in different areas. They all come from different areas. Teachers, some of us don't even live in the town we teach in. We live pretty far away, some of us, but we all come to the same spot. It's perfectly fine. That's an example of a function. Even though all of these input things over here, people, numbers, whatever, are coming to the same place, it's okay. That's why, by the way, this one was a function. Now, let me give you this example. Let's say you get up in the morning, you're like, you know what? I'm going to do this. I'm going to go to the high school. I'm going to go to Mechanicsburg. And at the same exact time, I'm going to go over to Trinity. And at the same exact time, I'm going to hit up CV. Now listen, you could do those 3 things in a day, but you can't do them simultaneously. So you cannot be mapped. You cannot go from one input value to 3 other places. Can't do it. That's why it's not a function. That's why this one right here is not a function, because this -3 is trying to go 2 different places. Can't do it. Impossible. No doubt it's a relation, but it's not a function. Okay? So there's some simple examples of that. Let's roll on to this. Whoa. Are these things functions? If I drew an actual graph, like this goofy thing right here, this quadrilateral thing, looks more like a rhombus or a diamond, whatever, triangle, circle. Are these things functions? Well, we have this thing called the vertical line test that will help you determine if graphs like this are functions or not. And here's the simple way to do it. If you look at a picture like these, or like this one right here, you draw a vertical line. Whoa, hence the name vertical line test. And as you would draw this vertical line anywhere, you can see it coming across your screen. If at any point, here's your definition if you want a vertical line test definition. If at any point of this vertical line going down through your graph, if it intersects that graph in any more than just one spot, which means we have more than one output value for an input value. Keep in mind, this red vertical line represents your output values. It represents, if you will, your range. Where it's going through the little x coordinate right there, that's the domain. That's the input. The x coordinate is the domain. Here's an output value. Here's an out. Here, let me do this. Here's one of your output values. If I stopped it there, here's one of your output values, and here's one of your output values. Ladies and gentlemen, that's a problem. We have one input value right here of x equals -2.2. But it looks like I'm going to have 3 different output values. That is not a function. So anytime you have a vertical line that goes right down through a graph, anywhere it is, no matter where it is, if it intersects more than one spot, not a function. So the example that you see on your screen, definitely not a function. Well, what about this one? Well, if I drew a vertical line anywhere, here's an example. If I drew that vertical line, it's only intersecting one spot. And I don't care if you draw the vertical line here, here, over here, it's only going to intersect in one spot. Ladies and gentlemen, that right there is an awesome function. You got it. How about this one? Certainly is a function, because no matter where I draw the vertical line, it's only intersecting it at one spot, and that's it. So there's your vertical line test. It's pretty simple. Are these functions back to these things? This one right here absolutely is. Vertical line test, it passes the vertical line test. If I have this one right here, it fails the vertical line test right there. It intersects 2 spots. This one fails right there. 2 spots intersects, not a function, not a function. This one right here, it fails. In fact, it fails a bunch of times right there, infinite number of times, because that vertical line is intersecting a bunch of times right through there. So that one fails. So there's really only one that's a function in this picture. So here's your CPQ question, and I want you to do this. Take those 3 things, and in your Google form, just put A, function, or B, or A, not a function. B, function, B, not a function. C, function, C, not a function. And we'll talk about these in class. You guys are awesome.
We'll see you later.